calculating an effect size. To essentially have to do the same thing, we need to calculate a R value, and we are given the z-score on the output. So all we need to do is go ahead and calculate that for both the 3 hours and the morning. And it looks like that we have a very large effect in the 3-hour test and a small to medium effect in the morning test, which means that the 3-hour test was not only statistically significant, it was also practically significant. All right, we're going to go ahead and move on to the Wilcoxon signed rank. So here is where we're using the same participants. So this is the dependent t-test version. So it's doing very similar things. It's still ranking the data, again, starting with the smallest, and then it's assigning positive ranks and negative ranks. So it's actually calculating the difference between the groups and then ranking the data after that. So we're going to look at an example of how this actually works. So you go through, you have your data set, and you're going to calculate the difference between the two groups. 27 minus 27 is a 0, and for anything that is a 0, we just simply exclude that from the data set. 24 minus 18 is a 6, so that is a positive sign. And you also have to keep in mind exactly how you are doing the differential, because this is the 3-hour minus the morning test. All right, and then given the data, we're going to go ahead and rank the data. Now, a lot of the things you're going to have to look at is we're going to have some positive ranks, and we're going to have some negative ranks. So the positive ranks are here, and your negative ranks, obviously here. And if we happen to have, again, ties, we're going to take those ranks. It would have been 1, 2, 3. 2 plus 3 divided by 2 is 2.5. So that's why you have positive ranks of 2.5. We've got another tie here. A tie at -8, a tie at -7. So that's why we end up with these half values over here, is because we do have a ton of ties. All right, so then the next thing we're going to do is we're going to sum up the positive ranks and the negative ranks. So for one drink, so if we're looking at the one drink data, the number of positive ranks, we're going to sum that together. It was total 36. We do not have any negative ranks with one drink, so T negative is 0. So our test statistic is the lower of the two, so T is equal to 0. For no limit, we're going to do the same thing. T positive, we have an 8, and T negative, these add up to 47. We take the smallest of the two for the test statistic, so that test statistic is 8. All right, then what we're going to do is we're going to go ahead and calculate the t value and the standard error value by some real easy equations. Something to note that we did have a sample size of 20, but for one drink we had to eliminate 2 of those cases. So that does change our sample size down to 18. So that's something easy to note, that when you do eliminate things, you also have to change your sample size. All right, next thing is to calculate the z-score. We'll have to do that for one drink and no limit. All right, and then we know that if our z-values are greater than 1.96, then we have a significant test. Looks like we have both significant tests. Now let's go ahead and look at the SPSS. What's nice about SPSS is that it will let you change your data set. Sometimes if you enter your data in columns, you're going to have to change that around, but you can do that to make it work. Just have to do a data split, but save your file regardless because it's going to change it. All right, how do we do this? We're going to do kind of very similar to what we did for the other ideas. So here's our output. All right, so where do we want to start here? We're going to look at the fact that you can either look at the negative ranks and the positive ranks. So when it's based upon negative ranks, you can conclude that there's a significant increase in lane position that occurred from the morning after as compared to 3 hours when comparing the one drink limit. Right, so we have the 3 hours minus the morning test. We have a significant difference. All right, so 3 hours minus morning. So when it's based upon negative ranks, that's what we're looking at. When based on positive ranks, you can conclude that there's a significant increase in lane position from 3 hours to the morning after when compared to no limit. So there's your no limit based upon negative ranks. So let me write that down. Okay, so that's the first conclusion that we have. How do we know it's based on negative ranks? Right, right there. Our test has an A. So A says based on negative ranks. So because this is a ranked test, we always have to preface the sentence with when based on negative ranks, there's a significant increase in the lane position from morning as compared to 3 hours. Because of the way that we're testing this number, it is a negative z-value, which means 3 hours is less than morning. So there's a significant increase from morning as compared to 3 hours when looking at the one drink limit. All right, now let's look at the no drink limit. We have a B based upon positive ranks. based upon positive ranks. There is a significant increase in lane position from morning as compared to 3 hours, because again, it's that negative number. When comparing no limit. And those are obviously both based upon a 95th percentile confidence level. So that is exactly how you report your findings from this test. All right, and then the very last thing we want to do is we're going to want to be able to calculate a z-score using a simple equation. So we have a large effect for one drink and a medium effect for no drink. So we do have a practical significance that's appearing in both of these. We have a statistical significance as well for both. So important to note. All right, that's pretty much how you handle non-parametric. So you can go ahead and give your homework a try, and I'll post all of the associated tasks here that we've run on Blackboard so you can at least try what we've done here in class.